Okay, we are simplifying radicals. There's a couple things I want you to know or remember. Okay, a square root, what does a square root cancel? Something that's squared. Okay, so what would a cube root cancel?
Something that's cubed.
Okay, so something to the fourth power. I mean, so our fourth root would cancel something to the fourth root, so on and so forth, right? Fifth root cancels something to the fifth power, and that keeps going forever. So what I want you to realize is they have to match to cancel. So if you look at this first one, we have 36 x squared y squared, the square root of that. Well, isn't 36 a perfect square? Yeah, if you look at your paper. Okay, 36 is 6 squared. So what's the square root of 36? 6. Now, the square root cancels the squared for the x and the y. So what's left? xy. Well, 6xy. Because this is the same thing as saying 6 squared. So it cancels the squared, the squared, the squared, and you get 6xy. Okay, now number 2 is different. Okay, it's still a square root. 48 is not a perfect square, and you'll notice these are not squares. So nothing just like cancel, cancel, cancels, and we're done. So 48 is not a perfect square, therefore, how do we simplify radicals when they're not perfect squares? The factor tree. So I like even numbers because I can do 2 and 24. I just cut it in half. 2 and 12, 2 and 6, 2 and 3. And it's a square root, so I'm looking for things that match twice. Well, the 2 matches twice. Here's 2 2's. And then I have a leftover 3. Well, we multiply. Whenever we have multiple things we get to take out, we multiply them. So what's 2 times 2? 4. So we're going to take out a 4. And then I'm going to leave some space because we have some letters to figure out. And we have a 3 left over. So far, this is what we have. Yes or no?
Yes.
Okay. Now, I'm going to draw out my x's and my y's, almost like a factor tree-ish type thing for my variables. You don't have to do this every time, but I want you to understand why I'm asking the questions I'm asking. So x to the 6th, 4, 5, 6, is this. Well, look, 1, 2, 3. Isn't that a pair 3 times? Okay, well, if we multiply x times x times x, what do we get? X to the 3rd power. Was there anything left over to put back in the house? No. So then we have y 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, look, 1, 2, 3, 4 pairs, so y to the 4th. But we had a leftover, so it has to go back in the house. So there's your answer. But here's the way I'm going to ask it. I'm not going to write it every time. Now, can you if you want to? Yes. If you like writing it out because that's you're a visual person, then you do that. But you can ask yourself, square root is the same thing as putting a 2 here, like a cube root puts a 3. 2 goes into 6 how many times? 3, perfectly, right? With nothing remaining. That's why there was no x left over, and that's why we took out a 3. 2 goes into 9 how many times? 4 times pretty with 8, right? And what's remaining? How many are remaining? That's why 1 went back in. So you can always ask yourself, 2 goes into that how many times? 2 goes into that how many times? That's what you're taking out, and whatever's remaining is what's left over. So my final answer is 4xy, sorry, x cubed to y to the 4th, square root 3y. Okay, let's try another one. But what's different about number 3?
They got a cube in front.
It's a cube root. Okay, what cancels a cube root? Or what does a cube root cancel? A cube. So you need something to the 3rd power to cancel. With squares, we needed something that matched twice to cancel. Now we need something to match 3 times. 81 is not a perfect cube. Now I will tell you, this is kind of a hint. Negatives Odd, that's odd, not add. Odd roots allow negatives. Even roots do not. So if an even root has a negative, it's imaginary. But an odd root has a negative, you just take a negative out. It's not a big deal. And the reason being is, think about it this way. What's a negative times a negative?
Positive.
Times another negative?
Negative.
Yeah. Every time you multiply a negative by an odd amount of times, it turns back to a negative, and that's why it's allowed. Okay? So, but if you do it an even amount of times, they always cancel, and that's why you can't do it when it's even. So knowing that, we can take out a negative. I'm just going to go ahead and take it out now so I don't forget. And I'm going to break down the 81. Well, 2 doesn't go into 81, but 3 does. 27 times. 3 goes into 27 9 times, and then 3 and 3. Now, before you circle anything, we have a cube root, meaning we need it to match 3 times. So there's 1, 2, 3 3s, and a 3 left over. I can't circle something that matches twice. I need it to match 3 times because it's a cube root. And remember, this is the same thing as saying 3 cubed, and the cube root cancels the cube, and that's why we can take out a 3. So I'm going to take out the 3, and I have a cube root with a 3 left inside, that leftover 3.
We don't have to worry about the plus or minus.
I took out the negative. That was just negative, not plus or minus. Now, 3 goes into 9 how many times? 3 times. So m to the third, and that was perfect. 3, 6, 9. So that's perfect. Now, 3 goes into 5 how many times? Once, with how many remaining? 2. And if you needed to see a visual, there's 3, 4, 5, and so you have a group of 3 that get to come out, and then 2 remaining. So there's your answer. So negative 3m to the third n, 3n squared. Thank you. Sounds good. Any questions with that? Okay, so let's try number 4. Now the difference here is you have a negative in front already, so let's bring that down, because if you're like me, you're going to forget about it if you don't. So we have 32, which if you needed to check is not a perfect cube. Okay, 8, 27, 64, not a 32. Okay, so we do have to break it down. 2 goes into 32 how many times? 16. 2 goes into 16 8 times. 2 goes into 8 4 times. And then 2 and 2. Now this is a cube root, so we need it to match 3 times. So 1, 2, 3 2s. And then we have 2 left over. So we get to take a 2 out. And then 2 times 2 is 4. You remember, you multiply them back together if they can't take them out. Three goes into 3 how many times? 3 goes into 5 how many times? With how many remaining? So again, if you need to draw it out whenever it's not perfect, there's your 1 that came out and then your 2 that were left over. But 3 of them goes perfect, so there was nothing left over.
Wait, where did you get the 4? Oh.
What 4?
Animosity.
The 2 times 2.
Yeah.
Your leftovers. Okay, so nothing here simplifies, so I have negative 2xy cube root 4y squared. Now you'll notice when I do cube root, do y'all see how I kind of put the 3 in the middle of that root symbol? If you write it too big up here, it almost looks like negative 2xy cubed, but that's not y cubed. It's negative 2xy cube root. Do you see the difference? So be careful. Always try to make sure it looks like a cube root, not a cube for a different letter. Okay, let's look at example 5. So again, it has something out front. Don't forget to bring that down, because if you're like me, you're going to forget it if you don't. This is a fifth root, meaning I need something to match 5 times. So I have 160. I'm going to start with 2, because then I can just cut it in half. What's half of 160? What's half of 80? Half of 40. 20. 2 is 10. 2 and 5. And again, it's a fifth root, so I need something to match 5 times. So do I have 1, 2, 3, 4, 5 2's, which is perfect, meaning I can take that 2 out, and I have a 5 left inside. So I'm going to take a 2 out, and a 5 left inside.
So basically what I'm getting then every time is going to be whatever is the number
The root.
The root is going to also be inside of it.
Yep. Yep, that's what it pretty much tells you what to do. So 5 goes into 6 how many times? 1 time. And how many remaining? 1. And if you need to draw it out, there's 6 x's, so there's 5, and then 1 left over. And then 15, does 5 go into 15 pretty? Yeah, how many times? And then there was no y's left over, because 5, 10, 15, that's perfect. So negative 4 times 2 is negative 8. And there's your answer. Now, last one, I'm going to actually do the numbers for you on this one because I just want to go over the letters again one more time, and then we'll do practice. So 6 was already there. On this one, when you break down 324, you can take a 3 out, and this is a 4th root, and you have a 4 left over because I had 2 2's, so 4. Now, 4 goes into 6 how many times? 1 time. So we could take 1 m out, and that's with 4, so 5, 6, that's 2 remaining. And if you need to draw it out, there's your 1 that you get to take out, and there's your 2 remaining. 4 goes into 10 how many times? Twice. With 8, right? Oh, dang it, I was about to write 8. 2 times with 8. And how many's remaining? 2. Again, if you need to write it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's your 2 that you got to take out, and your 2 that were left over. So then just simplifying, there's your answer. 6 times 3 is 18. Mn squared, 4th root of 4m squared n squared. And then if you flip to the practice when you're done writing that down, there's 2 things I want to tell you about the practice. One through 7 are all going to be pretty answers, no radical left. Okay? They're easy. If there's no letter, you can literally type it in your calculator. If there's a letter, though, you cannot. Look at number 3. When there's a fraction, you can break it apart. And if you look at your paper, 27 is a perfect cube, 3 cubes, so that's 3. And 64 is a perfect cube with 4 cubes, so 4. So there's your answer, 3 over 4. Okay? Okay, if you look at number 7. It has a negative, but it's an even integer. What did we say if it's, not integer, sorry, root. Even root. It's going to be imaginary. So, Then you go look at your the fourth roots. Here's 81. It's 3 to the fourth power, so it's just 3. So 3i is your answer. Okay, the rest of them, 1 through 7, like I said, are going to be no radicals left in your answer. But 8 and on will have radicals.
Every question.